Okay, so normally I don't actually have the answer written out, and I write it out and work through it with you, but this one's just done so much quicker if I have it written out and can talk to you, and then you can take it down yourself or work through it yourself as well. So when a loan of P is repaid in equal repayments, so equal repayments, you should be thinking alarm bells straight away. That's probably amortization of an amount A, so each repayment amount is A, at the end of each of T equal periods of time, where I is the periodic compound interest rate expressed as a decimal. The formula below can be used to find the amount of each repayment. So the amortization formula, show how this formula is derived. Derive the amortization formula. Now, it really wasn't very well answered. Not a lot of it, like most people will cover it, but not put a huge amount of effort into it. The marks for it were only 3, 0, 3, 4, 5. Okay, so at least if you're coming up to exams and you get an exam question like this that you've no clue, take a bit of solace that it's probably not worth a huge amount of marks. Don't freak out. Do your best with it. Okay, so we know the loan amount was €P. It says it in the question. The repayment amount is €A. Each repayment is A. The number of years is T, or the number of repayments is T, and the interest rate is I. Write A in terms of P, T, and I. Okay, so the present value of the loan is P, the present value of the first repayment. So this is sort of going backwards in time. Imagine a year after taking out the loan, you go and repay the bank a certain amount. Well, it's asking what is the present value of that amount that you're going to pay the bank back. So it's A divided by 1 plus I. So the current price of the first repayment after 1 year's interest. Now, what would the second amount be? So the current price of the second repayment after 2 years interest. Okay, so you might see a bit of a pattern here. Okay, so the actual present value of the teeth, or the last, or the general term of any repayment, can be found like this. Okay, so the current price of the teeth repayment after T years of interest. Okay, so what we can find then, that this forms into a geometric series where this is the loan amount, this is each single repayment. The loan amount is equal to, so again going back, the loan amount here is equal to the sum, or all of the current values of each repayment added up. Okay, the current value. So once you've gotten this far, you should spot that it's a geometric series. And then you go back and sort of look at the question, well, what do you want to get on its own? You want to isolate A. Okay, we want to isolate A. So it's a geometric series. Well, what's the common ratio? Okay, the common ratio, well, what would you have to multiply this by to get to this? Okay, top by top, bottom by bottom if you're multiplying fractions. So A by something is A by 1. And then 1 plus I by something is equal to 1 plus I squared. Well, obviously 1 plus I. The first term, small a, is quite clearly the first term there. And N is the number of terms, which is T. So put that into the sum of geometric series. Okay, here's what it'll look like. Okay, now it looks a bit mad and a bit chaotic. Don't panic. So the first thing we have to try and identify is how to get rid of this fraction here. Okay, so what we're going to do is multiply top and bottom, same as multiplying by 1, okay, because that over itself is 1, like 7 over 7 is 1, so we're allowed to do that. And what it has an effect of is going 1 into here, you'd get this section, and this getting multiplied in here, you just get the minus 1. Okay, so if you can keep your mind focused on how do you get rid of that, life will be made an awful lot easier. And then multiplying this 1 plus I into the top line, you don't multiply it into both brackets, okay, just multiplying it into 1. Remember, it's like 2 by 3 by 4. You don't multiply that 4 into both brackets. You only would multiply it into one of them. Same here, it'll have the effect of getting rid of the bottom line of that fraction. Okay, so we're in a much better position now, and actually on the bottom line we end up with just I, okay, because the 1 and the minus 1. So when we have the single I here, we multiply both sides by the I, okay, to get rid of the fraction. Now on the log tables on page 21, dealing with this section here, we can use this rule from the log tables here. So the top line should be 1 to the power of t, but 1 to the power of anything is just 1, so you can just leave it as 1. Now, coming from here to here is a little strange, and this right here is incredibly useful for adding fractions. Okay? Any type of fractions, algebraic fractions, simple fractions, anything, but it makes your life an awful lot easier if you can remember a over b plus or minus c over d. How to add those two fractions? It's top left, so a, by bottom right, which is d, plus or minus. Now if it's a addition, it'll be plus. If it's subtraction, it'll be minus. So plus or minus top right, which is c, by b, all over bottom by bottom. Okay, b by d. That's what happens here. 1 by 1 plus I to the t. Here, top left by bottom right. Minus, because it's minus, 1 by 1 is 1. Bottom by bottom. And then simplify it and bring it back in there. Okay, and after that then, we need to go and multiply both sides by 1 plus I to the t. So it'll be pi by 1 plus I to the t, and then divided by all of this. And voila, you have a on its own. And that's the question answered. Okay. So it looks like a really, really long question, and to be fair, it is quite long. There's quite a bit of learning to do in it, and I can kind of understand why it was answered poorly. But if you go through it slowly, step by step, it's not that bad. And one thing, like key point that I would try and remember is this point. The first step, because you're trying to get rid of that fraction right there. You can't remember the first step, you're not going to be able to remember the rest of the question. Okay, so that's really the key step. You might be able to fumble your way through it after that, but that first step is the most important bit. Okay, so you'll be glad to hear it gets a little bit easier from here. The question asks, Alex has a credit card debt of €5,000. One method of clearing his debt is to make a fixed repayment at the end of each month. The amount of this repayment is 2.5% of the original debt. So it's 2.5% of that number. It's not a sum that changes at all. Okay? So 2.5% multiplied by €500, making sure to use the percent, or €5,000, making sure to use the percent button on your calculator, and you can get that. Of course, there's many other different ways of doing it. You could do 5,000 by 0.025, and you'd get 125. Okay. Remember the previous question was only 5 marks? Well, 10 marks. They're really trying to make up for it. The next question is quite nice. It's asking you to change an annual percentage rate to a monthly percentage rate. So the monthly interest rate that is equivalent. So FPIT. Imagine you started off with €1 and you end up with €1.2175 at an interest rate. Well, we know what the interest rate was, and it was in for a year. Okay. Imagine this is your year. Now imagine we did it 21.75. Imagine we do it monthly. Well, we want the initial amount to be the same. You want the final amount to be the same. We want, well, we don't know what the interest rate is. and we want it to be compounded monthly. So now applying this into our compound interest rate formula, 1.2175 is equal to 1 plus I to the power 12. Now we are just looking for that I. 1.2175 divided by 1 is still 1.2175. 1 plus I to the power 12. We're going to take the 12th root. 1.2175 is equal to 1 plus I. I is equal to the 12th root. 0.2175 minus 1. I is equal to what is it? 0.016535, and then as a percentage, that is 1.65%. I think I lost a little bit out the front here. F, P, I, and T. And again, really nicely, 0, 4, 10, 2 ridiculously easy questions. Okay, next question. Assume Alex pays the fixed monthly repayment A each month and does not have any further transactions on the card. Complete the table below to show how the balance of the debt of €5,000 is reduced each month for the first 3 months, assuming an APR 21.75% charged and compounded monthly. So we already know how much he repays each month. 125, 125, 125. Okay, so now we need to find the interest. So to find the interest, or what goes in here, we need to find 1.65% of the €5,000, which happens to be 82.50. Okay, so he's paying back €125. He still is charged 82.50 on interest, so he really only pays back this much, or his balance reduces by that much. Okay, so now next we need to find the balance for the next year. Sorry, the interest for the next year. So he's just subtracted 42.50 from that to get that number there. So now how much interest is he charged here? Well, we need to go and find 0.65% of this sum right here, which happens to be 81.80. Taking that away from 125 is 43.20, and then the new balance is 4914.30. And again, we need to find the interest that is being charged on this sum, which is 81.09. How much he pays back then after the interest. And then subtracting 43.91 from 4914.30 to get the new balance at the end of the third year. Alright, points for this question, again, or marks for this question, 0, 5, 8, 10. So the last 3 questions have been 10-mark questions, bar the first one, which was only a 5-mark question. So the next part here is asking us to find out how long it'll take him to clear the debt. If he's borrowed initially €5,000, he's repaying €125, and the interest rate is 1.65%. How many months it would take him to pay that off? Now they say we can use the formula that we've already derived, which is the amortization formula. And even if you couldn't do the derivation, you can still use it. Okay, so what are we looking for? Write out the formula. What letters do we know? What letters do we not know? We want to find out how long, so that's T that we're going to be looking for. So you might as well fill in what you know anyways. 125 is equal to 5,000, 0.0165. because we always put it in as a decimal. 1.0165 to the power of t. 1.0165 to the power of t minus 1. So you could think about that €5,000 as being over 1, and it would get multiplied into this fraction. So these two, the €5,000 and the 0.0165 would get multiplied together. 125, and we end up with 82.5, 1.0165 to the power of t. Okay, we can also, well, we won't do it yet. 1.0165 to the power of t minus 1. Now, how will you get rid of the fraction here on the left hand side? You can multiply both sides by the bottom line, on the right hand side, sorry, multiply both sides by the bottom line. So if you multiply the right hand side by the bottom line, it'll just be removed. So it's on the left hand side then, going to be 125 by 1.0165 to the power of t minus 125 is equal to 8250, with a little glitch, 8250, 1.0165 to the power of t. Bring all the variables to one side, so 125, 1.0165 to the power of t minus 8250 by 1.0165 to the power of t is equal to 125. Add these two together or subtract them away from each other. Okay. And we get, what do we get? Calculator, 125 minus 8250 is 42.5, 1.0165 to the power of t is equal to 125. 1.0165 to the power of t is equal to 125 over 42.5. Now, this is like what we've had in this entire paper before. Again, you can use page 21 of your log tables. Okay, so it's log to the base 1.0165. Page 21, top right hand corner of your log tables. And up here we'll have 125, 42.5 is equal to t. And t is equal to, type that into your calculator, 1.0165, 125, we get 65.9 to the nearest month, t is equal to 66 months. Okay, so again, how many marks for this question now? 5 mark question, so you can take what that from you will, but what I would take is that it wasn't amazingly well answered. Okay, so they really loaded the questions quite nicely earlier on. Okay, so the next question, Alex decides to borrow €5,000 from his local credit union to pay off this current credit card debt of €5,000. Alex is mad for debt. The APR charge from the credit union loan is 8.5%, so that's annual, APR annual. 8.5% fixed for the term of the loan. The loan was to be repaid in equal weekly repayments, so it's annual to weekly. Okay, so FPIT, and we want to find out the amount of each weekly repayment. So we're going to use the amortization formula and find out what A is. So FPIT first, he starts off with €1, he ends up with €0.5. It's in for 1, and then the interest rate was 0.085. It's in for a year. Now we're going to change it to weekly. We want the F to be the same. The P starts off with €1, he ends up with €1.08. Okay, what else? Now, we don't know the weekly interest rate that we want, but we do know we want it to be in for 52 weeks. So F is equal to P, 1 plus I to the T, 1.085 is equal to 1 plus I to the 52. So it's the 52nd root of this is equal to 1 plus I. I is equal to the 52nd root, 1.085 minus 1. I is equal to the 52nd root. Where are we going? Here we go. Which is 1.5707 by 10 to the minus 3. But we want to put that. So when we put that into our calculator, we get this out. Sorry, not when we get it into our calculator, when we put it into decimal form, we get this out. Now, what's this going to be? This is going to be the interest rate for using it in the amortization formula that we have up above. I'm just going to slide this in from the side. So we can rush on through the question. I'll leave it there. So looking at the amortization formula that we have taken down from directly above, what's the A stand for? Well, sorry, the P, not the A. The P is €5,000, and that's how much they initially borrowed. The I is the interest rate, and the T is how many weeks it's in for. The I is the weekly interest rate as a decimal. Filling it all in, fill it straight into a calculator and get €36.16 out. Quite a nice question actually. 0, 5, 8, 10 again, which is a really, really nice marking scheme. So how much will Alex save by paying the loan off by using... Sorry, how much will Alex save by paying off the credit card debt using the loan from the credit union? So that is the difference between 66 repayments at €125 and 156 repayments at €36.16. Okay, so the difference between the two, and he saves €2,609 and 4 cents. 035 again. Okay, so really the only very hard part of this financial maths question was the very first question, the derivation of the amortization formula. Apart from that, quite doable.